Right. Assalamu alaikum warahmatullahi wabarakatuh. Hi students. In this video, I am going to teach you the first unit of grade 10 called perimeter. So these are the objectives of the course. By studying this lesson, you will be able to find the perimeter of sector of a circle and solve problems related to the perimeter of plane figures containing vectors of circles. I will teach you what they mention using the objectives of the course. So before that, we have to know what we have already studied in our previous class. So in our previous classes, we have studied how to find the perimeter of plane figures like rectangle, square, triangle, and circle. So the equation for finding the perimeter of a rectangle is mentioned here, 2 into length plus breadth. So here in rectangle, we have breadth and length. So we are going to add length and breadth and multiply the sum of length and breadth by 2 in order to get the perimeter of a rectangle. Likewise, we are going to find this perimeter of square. So as far as square is concerned, we are going to simply multiply the length of a side by 4. Right. Likewise, triangle. So we already know triangle has 3 sides. So the sum of all the 3 sides of a triangle is called the perimeter of triangle. Again, circle. So circle, for perimeter of a circle, we use the equation 2 pi r. So using the knowledge we have gained in our previous classes, we are going to do these questions. So let me explain you. Okay, I think we don't need to draw anything on the board, right? So the first question, so this is a rectangle. So in order to find the perimeter, we are going to add the breadth and length. So 20 plus 10 into 2, the perimeter. So we denote perimeter using the letter P. So P is equal to 2 into 20 plus 10, which is equal to 2 into 20 plus 10 is equal to 30. So the answer is 60. And the unit is centimeter. So we need to put centimeter. So this is the answer for the first question. And the second question, here you can see that is a square. So for the second question, perimeter is equal to 4 into 1 length of the square. So it is 7 centimeter. So the answer is 4 into 7, 28 centimeter. So this is the answer for the second question. And the third question is related to a triangle. So it is a equilateral triangle. You know there are several kind of triangles. One is isosceles triangle, equilateral triangle, like this. So this is an equilateral triangle. So the answer is, that means if this side is 12 centimeter, all the 3 sides are 12 centimeter. That is why they have put this mark. So P is equal to 3 into 12 centimeter, which is equal to 36 centimeter. So this is the answer. And moving to the fourth question. So fourth question is like a complex one, but that is not. As you think, that is also a simple. So in order to explain you clearly, let me draw the diagram. So they say this is 12 centimeter. Right. I did sketch the diagram of fourth question. So here, each angles are right angle, and this is like a complex figure. But in order to in order to convert this figure to a known figure that we are familiar with, I am going to move this side here and move this side here. So I am just erasing this line and bringing that here. Again, I am erasing this side and I am bringing that side to here. Now now it has become a rectangle. But you already know what is the perimeter of rectangle? Breadth plus length into 2. So 2 into 8 plus 12. So 2 into 8 plus 12 is 20. So what is the answer? 40 centimeters. So we need to be very careful. In the examination, we should mention the unit. Otherwise, we will lose the marks. And this is also same as the previous question. So I am bringing this side here. So I am bringing this side here and this side here. Now it appears as a square. So what is the perimeter of a square? P is equal to 4 into 10 centimeter, which is 40 centimeter. Right. Moving to the last question. Sixth question. Sixth question is a circle. So this is a circle. The radius of a circle is 7 centimeter. But we use the equation C. So normally, perimeter of a circle is circumference. So we denote C. C is equal to 2 pi r. So 2, instead of pi, we can replace 22 by 7 or 3.14. But since it is 7, I'm going to use 22 by 7 into 7. So I can delete these 7s and 44 centimeters. So that is the circumference. Circumference means perimeter of a circle is called circumference. So we denote as C. Right. Moving to the second question. This question. Find the perimeter of the following figure. Right. I hope you can see the board. So this question, we need to find the perimeter of this figure, but you already know perimeter means the outer edge of a shape. So we are going to start our journey from here. So starting our journey from here, I am going to reach the initial stage. So I'm going to add all the values of each side along which I am traveling. But here, if you see this portion, these lines are represented using dot line. But the rest are in solid line. But we are not going to include the dot lines when we find the perimeters. That means we are not going to include them. So for finding the perimeter of this shape, I am going to start my journey from here. So this is 4 centimeter. If this is 4 centimeter, it is also 4 centimeter. That is clearly mentioned in the yes. Right. If this is 4 centimeter, that is also 4 centimeter. Again, if this is 3 centimeter, this is also 3 centimeter. And for 3 centimeter, they have used this mark. And here, this mark is coming here as well. So this is also 3 centimeter. And this is also 3 centimeter. If this is 6 centimeter, this is also 6 centimeter. That's all. Okay, now I'm going to, before I travel, I need to find the length of this side because I need to include that side as well when I find the perimeter. So how can I find that? You know, in a right angle theorem, we can apply a theorem called Pythagoras theorem. So what Pythagoras theorem says, I don't think I should explain you that much. because you know Pythagoras, triples of Pythagoras. So 3, 4, 5. So this is the triples of Pythagoras. You should remember this. That means if the adjacent sides of a right angle triangle is 3, 4, the hypotenuse will be 5. That means triples mean if I multiply this value by 2, I will get 6, 8, 10. That means this is 6, this is 8, and this is 10. If I multiply by 3, 9, 12, 15. This is 9, this is 12, and this is 15. These are all triples of Pythagoras. So if this is 3 and this is 4, definitely, apparently, obviously, this is 5 centimeter. Just we need to add the values of each sides to find the perimeter. So starting my journey from here, 4, P is equal to 4 plus this side, 3 plus this side, 6 plus, again this side, 3 plus, again this side, 6 plus, this side, not this side. I'm not going to choose this part. I have to turn by this side, by this part. So 5 plus 3. Again, I don't need to add this 4 because I have reached my initial point where I started my journey from. So I don't need to put this plus mark here. So what is the answer? 4 plus 3 is equal to 7. 7 plus 3 is equal to 10. 10 plus 12. 22. 22 and 30. So that's the simplification. So the 30 centimeter is the answer. So 30 centimeter is the answer for the second question. Right. Moving to the chapter for the grade 10. So far we have discussed what we have learned in our previous classes. Now I am going to move into the chapters for this term, grade 10, the new chapter. Right, sector of a circle. Before that, let me explain you the components of a circle. So components of a circle. Right? Now, if we take a circle, we are going to draw a circle using a compass. The point where we place our point of the compass is called center. This is center. Right? Again, the locus of the pencil. So the locus of the pencil is called the circumference. That is simply perimeter of the circle. So this is circumference. Again, the line drawn between the center and the point on a circumference is called radius. R. We denote as R. So radius. And the plural of radius is radii. Again, the length between the 2 points on the circumference which goes through the center is called diameter. So this line goes through the diameter. So we denote what? D, diameter. Again, the length. So a line drawn between 2 points on the circumference, but which does not go through the center is called chord. So this is chord. This is chord. And you know this is segment. This is segment. An area bounded by a part of a circumference, and the chord is called segment. Now we are going to see what is a sector of a circle. So that is our scope. That is our objective. Okay, let me draw another circle here. Right, this is a circle. So for a circle, we can draw an infinite number of radii. So I am taking two radii. So I have taken two radii, and you know this is R. So we have minor arc and major arc as well. So I have taken two radii and a part of a circumference. So the area bounded by the part of a circumference and two radii is called sector. So this is sector. You can see it in your book as well. This is sector. Right, here you can see, so this is the sector, the area bounded by the part of a circumference and two radii is called sector. So this angle ACB is denoted by theta is called the angle at the center, and it can take the value from 0 to 360. So if it is 0, okay. Now, this is the sector. This is center. We denote using the letter O. Any letter we can use. So theta. So theta can take the value from 360 to 0. Okay. So theta, the range of theta may be 0 to 360. So if that is 0, so if theta is 0, we can't find any sector. So we don't need to bother about it. If theta is 90 degree, so we call it as, so if theta is 90 degree, this sector is called quadrant. If theta is 180 degree, these are the special cases I'm telling. So if theta is 180 degree means this is 180. So in that case, a portion of the circle, or that is called semicircle. Semicircle. Now, the general equation for the perimeter of a sector is equal to P is equal to theta over 360 into 2 pi r. So this is the equation. If for 360, if for the complete circle 360, for 360 if the circumference is 2 pi r what is the length of the circumference for a theta? So that is called arc length. We call it as arc length. That is not perimeter actually, arc length. So this is the arc length. You know this is arc and the length of this arc length is equal to theta over 360 into 2 pi r. For the quadrant, the arc length is equal to, instead of theta, I want to put 90 over 360 into 2 pi r. If I simplify it, 1 and there are 4 90s in 360. So the answer is 1 by 4 into 2 pi r. So the arc length, quadrant's arc length is equal to this. 1 by 4 into 2 pi r. For the semicircle, instead of theta, I'm going to put 180 over 360 into 2 pi r. If I simplify it, there are two 180s in 360. So the answer, so the arc length of a semicircle is 1 by 2 into 2 pi r. So you should remember these values. But the general equation is this. If the sector makes 60 degree at the center, we are going to put 60 degree. Okay. So moving to the questions now. So here I have explained everything in your book. So arc length is equal to, this is the general equation, theta over 360 into 2 pi r. But you already know for a circumference, we have two equations. One is C pi b, C is 2 pi r. But you already know diameter is equal to 2r. So instead of this 2r, you can put pi b as well. So that is a general thing. And this is for a semicircle and this is for a quadrant. And if the angle is 120, so instead of this theta, we are going to put 120 and we can simplify. So if it is 110, so if the theta is 120, so instead of theta, I'm going to put 120 over 360 into 2 pi r. So here 1 and there are 320s. Otherwise, you can just simplify. You can eliminate these zeros and you can simplify by 3. But there are 320s in 360. So the equation would be 1 by 3 into 2 pi r. So if the radius is given, you can use 2 pi r. If the diameter is given in the question, you can use 1 by 3 into pi d. So if you use d, you should not place 2. If you use radius, you should multiply by 2 pi r. That is the equations. Okay. And here, if the theta is 270, the ratio or the fraction is going to be 3 by 4. Okay. And if the theta is theta, so this is the chart. For explaining you simply, they have used this chart. Right. Moving to the example number 1. Let me stop share. Right. You can see the question on your book. I'm just going to share my video. I will not have the screen. You can use your book. Right. So they have given a sector. So the circle is represented using dotted lines, and they have given like this. So this is the radius is 7 centimeter, and this is O. We can use O for representing center, and the angle at the center is 45 degrees. So for the first question says, what fraction of the circumference of the circle in the figure is the arc length of the shaded sector? So they asked to find the arc length. You know, there are two confusions. Okay, you have to be very careful. If we ask to find the arc length, you need to only find this length. If you are asked to find the perimeter of the sector, if you are asked to find the perimeter of the sector, you need to add these two radii as well. That means perimeter of the sector is equal to theta by 360 into 2 pi r plus 2r. You have to add these 2r in order to find the perimeter, because the perimeter is the outer sum of the length of outer edge. So here, starting my journey from here, I have to add this curved length and this radius and this radius. So finally, so r plus r. So this, so perimeter of the sector. Let me erase this. Perimeter of the sector is equal to curved length. So that means this length plus 2 times radius. So that is why I wrote like theta by 360 into 2 pi r plus 2r. 2r means there are r plus r. I am adding this r and this r. So r plus r is equal to 2r. Okay. Right. So the first question says, what fraction of the circumference? What fraction? Fractions mean? So here, 45 theta over 360. They are asking this portion only, the fraction. So 45 degree over 360. So if I multiply, if I simplify it, clearly there are 8. Okay. Let me. So the fraction is going to be 45 over 360. If I simplify it by 9 first, there are 9 and 40. And here, if I simplify by 45 over 360, there, if I multiply by, okay, if I'm simplifying by 9, so there are 5 9 in 45, and there are 49s in, there are 49 in 360. Again, simplifying by 5, I'm going to receive 1, and here 8. So the fraction is 1 over 8. And the second question says, find the arc length. So find the arc length. They are not asking the perimeter of the sector, just arc length. So arc length is equal to this fraction, 1 by 8 into 1 by 8 means 40. I want to write like this, 45 over 360. But I will simplify it as 1 by 8. 1 by 8 into 2 pi r. So I have been given radius. That's why I use this equation. If I am given the diameter, but definitely you will be given the radius, because a sector is formed by 2 radii. So they will not give the diameter. So you can directly use this equation. So 1 by 8 into 2 into 22 by 7 into the radius is also 7. So this will be eliminated. And here 1, 4, 2, 11. So 11 by 2 which is equal to 5.5 centimeter. You need to be very careful. You should mention the unit in the final answer. So the arc length is 5.5 centimeter. Right. Moving to the example 2. Example 2 is same as the first example, but the only difference is the angle in the center, the sector force. So, but they have not given the dot lines as well. So this is O, this is 120. So this they say, but in the picture they have not mentioned the diameter or what radius. But in the sentence they say the arc length of the sector in the figure is 44 centimeter. So they tell the arc length, this length is 44 centimeter. This length is 44 centimeter. Find the radius. They ask to find the radius. So this is not actually the same question like first question. This is somewhat different from it. So, right, 44 centimeter. But we know the equation arc length is equal to theta over 360 into 2 pi r. So this is the equation. So instead of arc length, I'm going to replace 44 is equal to, here theta is equal to 120 over 360 into 2 into 22 by 7 into r. That's all. Only simplification remains. Only simplification remains. So here, you know, this is 1 and this is 3. So by practicing more and more questions, you will be familiar with these fractions. Again, this 2 into 24 is equal to 44. This 2 into 24 is equal to 44. Here also I have 44. So I can eliminate this 44 and this 44. So here 1 is remaining. So I can write 1 is equal to 1 by 3 into R here 1 by 7 into R. So R is 1. So I can bring these 3 and 7. So this is like 1 is equal to R by 3 into 7, 21. So R is equal to, from this I can tell R is equal to, by bringing this 21 here, R is equal to 21 centimeter. That's right. Moving to the third question. The arc length of the sector in the figure is 11 centimeter. Find the angle at the center. So we have 3 parameters: the length, arc length, radius, and the angle. So they can ask any question. They can ask any parameter. So here, without giving the angle, let me take it at theta. This is 9 centimeter and this is arc length is 11 centimeter. I'm going to write the equation. Arc length is equal to theta by 360 into 2 pi r. So arc length is 11 is equal to theta by 360 into 2 into 22 by 7 into 9. Right? So I need to find theta. So theta. Can I simplify? Yes. Here I can simplify. Here 1, but here 40. So again, here 1, here 20. Again, here 10, here 11. So I can eliminate these 11s as well. So theta is equal to here 10, and after simplification, you might forget these numbers. So only this 10 and 7 remain. So I have to bring these 7 and 10 here, but they are multiplied. So they are multiplied. So 7 into 10, which is equal to 70 degrees. So you should be very careful when simplifying. Okay, so therefore the angle at the center is 70 centimeter. If you want, you can write as mentioned in the book. Right. So I'm not going to explain all the so you can try these questions. Everything is same. Moving to the right. Again, finding the perimeter of a circle. So that's why I already explained you. When we need to find the perimeter of a circle, we have to add these two radius. Radius plus radius, radius. So this is the equation. So the perimeter of a sector is theta by 360 into 2 pi r plus 2r. So this is an equation. That's all. So going to the first question. Right, first question. Nothing new, just we need to add 2r, that's all. So here 120, this is 21 centimeter. We need to, the question says the figure denotes the sector of a circle of radius 21 centimeter with angle at the center 120. Find its perimeter. So we need to be very careful if we are asked to find the arc length, we don't need to add 2r, but if we are asked to find the perimeter, we need to add these two radii as well, because the perimeter means the outer edge of the figure. So arc length, let me write the equation. Arc length is equal to theta by 360 into 2 pi r plus 2r. So 120 over 360 into 2 into 22 by 7 into 21 plus 2 into 21. So that's the simplification. So according to BEDMAS, we need to simplify this separately and this separately. After that, I can add them. So here 1, here 3. Again, here 1, here also 3. These 3 and 3 will go. So 44 plus 42. So the answer is 86. 86 centimeter. Yes, I am correct. So moving to the question number 2. Example 2. Right. The perimeter of a sector, which is 2 by 3 of a circle, is 260 centimeter. So they tell the fraction. Indirectly, they have given the fraction. The fraction is 2 by 3. That means a perimeter of a sector, which is 2 by 3 of a circle. So this is fraction. So if we consider the whole circle, they divide the circle into 3 portions and they consider these 2 without considering this part. They have considered it. So they tell the perimeter means this line. So starting my journey from here, again with the curve length, I need to add these 2 radii as. So arc length is equal to theta by 360 into 2 pi r plus 2r. So arc length is given. What is that? 260. And this fraction is also given without giving the angle. They have directly given the fraction. So what is that? 2 by 3. So instead of 360, I have put 2 by 3 into 2 into 22 by 7 into what is R? Now we need to find the R. Again plus 2R. So I need to simplify. Right? Just simplification. So here I can't simplify anything. So 206 is equal to 4 into 22, 88 over 21 R plus 2R. So here 260 is equal to 21. So I'm taking 21 as LCM. So 88R plus 2 into 21R. So I substituted correctly. So here I'm writing here. So I'm writing this portion first. After that, I will put 260, 88, 88R plus 42R over 21 is equal to 260. So 88. So that is 0, 120, 130. 130 R over 21 is equal to 260. So if I simplify it, this 0 and this 0 will go. So here 1, here 2 times. So R is equal to R over 21. So here 21 is also here. So R over 21 is equal to 2. So R is equal to 2 into 21, which is equal to 42 centimeters. Right. So after that, they have given some examples. You can try them at home. I am trying to explain you the third question. I will explain you this question. I will explain you this question. You can try the rest by your own. So the question says, find the angle at the center of the third sector when the perimeter is 64 centimeter and radius is 21 centimeter. That's all. So here, roughly we can sketch a diagram like this. Okay. Now find the angle at the center. We need to find the theta. When the perimeter is 64. Perimeter means this side, this length plus these two radii. So perimeter. For perimeter, we know the equation. Theta over 360 into 2 pi r plus 2r. So here perimeter is given as 64 is equal to theta. I don't know. I will put theta 360 into 2 into 22 by 7 into r. What is r? 21 plus 2 into 21. So here 1, 3. So here 1, 120. So here 61. So here 30, 11. Right? So 64 is equal to here 11 theta over 30 plus only 11. Okay. Plus 2 into 21, 42. So I'm going to subtract this 42 from this 64. So I will receive 11 theta over 30 is equal to 64 minus 42. So which is equal to, let me write here. I think you can't be able to see it. Okay. So 11 theta over 30 is equal to 64 minus 42. So 11 theta over 30 is equal to 64 minus 42 is equal to what? 20. So theta is equal to 30 into 20 over 11. After simplification, you can find the theta. So it will become in decimal points. That doesn't matter. Theta can become in decimal points as well. But I need to check it. So in perimeter 64, theta over 360, 222 by 7, radius is 21, 2 into 21. So here 3, 60, 30, 11 theta over 330, 64, 42. So 20. Sorry. 22. I made a mistake here. Sorry, it may happen in the examination as well. So you have to be very careful. The examiner will not put you in difficulty. He will just check whether you have understood the concept. Otherwise, the simplification will be more easy than you expect. So here, 64 minus 42 is equal to 20. So here, 2, here 1, theta is equal to 2 into 30, which is equal to 60 degree. 60 degree, I made a terrible mistake. So that's why I didn't find the correct answer. I thought that the angle will become in decimal points, but theta may be decimal as well. But I'm not going to explain the second one. You can try it at your home. I want to move to the next part. Right. 1.3 is about the perimeter of plane figures containing sector of circle. Now we are going to find the compound figures in which semicircle or the sector is involved. So if you look at the example 1, so if you look at the example number 1, so let me sketch the diagram. So I have roughly sketched it. So this is 20 centimeter. This is better so that you can easily understand. Okay. So the question says the figure illustrates how a semicircle has been joined to a rectangle. No, that is not the question should be to find the perimeter of the figure. So let me explain you. So this is semicircle and this is a rectangle. So this compound figure is made of a semicircle and a rectangle, right? So the perimeter is equal to, I'm going to start my journey from here. So this curved area is half into 2 pi r. Do you agree? Why? This is because this is semicircle. For a semicircle, I can directly put half. I don't need to put 180 over 360. Definitely 180 over 360 is equal to half. So I can directly put half plus this side. So if this is 20, this is also 20 because you know the property of rectangle, the opposite sides are equal. So if this is 20, this is also 20. If this is 14, this is also 14. Okay? But, okay, no harm, I can. But I already explained you for a circumference. For circumference, we have two equations, 2 pi r and pi d. If we are given diameter, we need to use this equation. You tell me, this is the diameter of the semicircle. That is 14 centimeter. If I use the equation 2 by r, I need to put d is equal to 14. So r is equal to d by 2, which is equal to 14 by 2, which is equal to 7. Sometimes I may forget to do this. In that case, I need to use the equation pi d. Pi d. I better use this equation pi d. Otherwise, sometimes I may substitute instead of r, I can substitute 14 by mistake. And it will lead to a problem. You will end up with the wrong answer. Plus 20 plus this 14. So I started my journey from here. I have come along this path. Again, this path is 20. Again, this 14 plus this 20. And again, I have reached my initial point. So this is 20. So half into 22 by 7. So in that case, I didn't put 2. Why? I have used this equation. D is equal to 14 plus 20 plus 20, 40. 40 plus 14, 54. So here, 1, 2. I can eliminate these 2 as well. So 22 plus 54, 76 centimeter. Okay. Right. I have explained you the question number 1. So moving to the question number example 2, you can see the figure in your book. I will just sketch the diagram. Right. This is the figure that has been given in the example 2. So from this data, this region is shaded and they have given this is 15 centimeter and this is also 15 centimeter. From that we can tell this is a square and we need to find the perimeter of the shaded region. Okay, well. And this is, you know, this is 90 degree. And this, okay, these are same. Right. Now I need to start my journey from here. Okay. Starting my journey from here, I need to find the curved length of this part. So that is nothing but a quarter. So 1 by 4 into 2 into 2 pi r. Right? Because I'm a radius. So 2 pi r. Here, you know, this is 15 centimeter and this is 8 centimeter. If this is 15 centimeter and this is 8 centimeter, what is the length of this radius? 15 minus 8. So R is equal to 15 minus 8, which is equal to 7. So let me tell you, I will directly write all it, everything. So plus half in 1 by 4 into 2 pi r plus this length. This length. What is this length? This length is, so hypotenuse. So let me take it as x. X is equal to 8 squared plus 6 squared all whole squared. But definitely, this is triples of Pythagoras. So I can directly tell, you know, 3, 4, 5. So 6, 8, 10. So if this is 6 and this is 8, x is equal to 10. You can find this way or you can use this method, not me. In the examination, we need to reduce our time as much as possible for each and every person. So this is 10. So x is equal to 10 plus this 6 plus this 8 plus this 7. This is 7 centimeter. We have already found that is 7 centimeter radius. 7 plus again 7, and I have reached the initial point. So here 1 by 4. I think you can see this. 1 by 4 into 2 into 22 by 7 instead of 5 into radius 7 plus I need to add these values and put here. Okay, now tell me. Here 10, 10, here 6 plus 8 is 40. Again, this is also 40, 28, 30. 8, 30. So 38. So here I am going to put 38. So when you add, people tend to make mistakes in addition and subtraction. So you need to be very careful. 30. Now I can eliminate this 7 and this 7. So here 2, here 1, again 1, 11. So 11 plus 38 is equal to 49 centimeter. So that is the answer. Oh, sorry. 49. No, 53. I have made a mistake. Okay, there is no nothing wrong. I have found. So I have found the perimeter of the shaded region, but they have found the region, the perimeter of the region which is not shaded. They tell this is a lamina. So they cut off this region from a square lamina. So they have found what the perimeter of the region left out. So you can just, I have explained you how to find the perimeter of this region. But in the book, they have found this region. So here, you know, this is 11. We have found already this is 11. 11 plus this is 8. And this is 15. This is what? If this is 6, this is 15. So this is 9. Okay. So they add this 11 plus, I'm starting my journey from here. 11 plus 8 plus 15 plus 9 plus 10. So that is equal to 53. That's all. 53 centimeter. Right? Okay. Now we have exercise 1.3. You can try it. Now I'm going to explain you this question. This question. You can see it on your book. Stop this here. Right. A semicircular portion of a diameter 7 centimeter has been cut out from a semicircular lamina of radius 7 centimeter and welded to the lamina again as shown in the figure. Right? So from a big semicircle, so from a big semicircle, so this is a big semicircle. So this is the center of the circle. So from the circle, from the center and this terminal, they have cut off another small semicircle. And after cutting it, the left portion is attached here. And they ask to find the perimeter of this portion. So this is 7 centimeter. This is also 7 centimeter. So what is the curve? What is the perimeter? First, I am starting my journey from here. From here to here. From here to here. P is equal to half into 2. I am using 2 pi r, right? Because r is given. So I am directly writing down uh, half into 22 by 7. R is here. R is 7 centimeter because this is the center and this is the radius. This is 7. Plus, now I have found the length of this part. Again, I am coming to this portion. This portion, if you consider this semicircle, small semicircle, this 7 is not radius, that is diameter. So I am going to use pi d. But since it is a semicircle, I am going to use half into pi d. Half into, instead of pi, I am going to use 22 by 7 into d is 7. D is 7. In that case, I didn't put 2 here, but I have put 2 here because that's in the equations. Plus, again, this part. So I have this portion 2 times. So I can either multiply this by 2 or else I can again half into 22 by 7 into 7. So I can eliminate this and this and this, that is 22. Again, this and this, that is 11 plus 11 plus again this 11 is 11. So what is the answer? 22. So 44 centimeter is the answer. You can try the rest of the questions. And I will explain you one miscellaneous question as well. That is the last question, right? So a portion, you can read the last miscellaneous question. A portion, let me erase it. Right. A portion of a grill to be fixed to a window has been made by combining two equal sectors of circles as shown in the figure. The person making the grill states that based on the data, based on the given data, a wire of length 128 centimeter is required for it. Show with reasons that his statement is correct. So a person wants to make the grill, and he claims that he needs 128 centimeter of a wire to make the grill. We need to check whether his statement is correct or wrong. So there is a shape like a rhombus. And from the rhombus, we have two curved lines. And this is the shape of the grid. So there is nothing dot line. So we need this side, this side, this side, and this side. Okay. So this is 21 and this is 60. So we need to find the perimeter. Normally, we do not include the interior sides when we calculate the perimeter. However, in order to make this grill, we need to include this side, this side, this side, this side. And this is a design, right? So we need to include, we need this length as well because this is a grill. Generally, we already did a question like this. To find the perimeter of this compound figure, we didn't include this side. However, we need to include this side here in order to find how much length of wire is needed. Okay, this is a different case. This is perimeter means the outer edge. But here they don't ask the perimeter, they ask the length of wire needed for making this design. That's all. So here I need 21 by 21 times 4 because this side is 24, 21, this side is 21, and you know if this is 21, if this is 60, this is also 60. Okay, if this is 60, this side is also 21 and 21. So there are 4 times 21 plus we have similar curved lengths, two similar curved lengths. So 2 into 60 over 360. Why? I'm going to consider it as a sector. And the angle that makes at the sector is theta. Theta is 60. So 60 over 360 into, instead of 2 pi r. So 20 times 4. 21 times 4 is equal to 84 plus 2 into 60 over 360 into 2 into 22 by 7 into 21. Okay. Now this is 1, this is 3, and this is 1, 6, this is 2, this is 1, 2. So which is equal to 84 plus 22, 2. So 44. So what is the answer? 828. So his statement is correct. We did 128 centimeter. You need to clearly understand this is not perimeter. When we find the perimeter, we do not include the interior side. But here, in order to make this design, we need to include these curved lengths as well. And if this is 60, this is also 60. And like two sectors. These are two sectors. This is a sector. Again, this is a sector. So that's why. Otherwise, Otherwise, I can do it in this method as well. I hope you have understood this method. So this is one sector. This is one sector. This is one sector. I have another sector like this. So I am going to multiply 2 because I have two sectors, two similar sectors. 2 into the perimeter of one sector is 60 over 360 into 2 into 22 by 7 into R is 21. I didn't write the equation. So theta into 360 into 2 pi R. Okay. So this is 1, this is 6. Okay. This is, if I simplify by 3, 2, 3. And this will go. Wait. So I have two sectors, 2 into, instead of theta, I'm going to put 60 over 360 into 2 into 22 by 7 into 21. So here 1, 3. Here 1, 6. 1, 2. So yes. 2 into 22 is 2 into 22. The problem is I didn't include these 21. So I have this part is this length, this arc length. I have found this arc length. This arc length is, I slightly confused. So 2 into 22 is equal to 44. 44. 44 is these two regions, these two lengths. Okay. 44 plus 4 into 21, which is equal to 44 plus 40, 80, 84 which is equal to 128. So we need 128. So I confused. So initially I considered the arc length. I didn't put, otherwise I would have put like this plus 2r, but sometimes it may confuse. So you better find the length individually. Okay. With that, I am concluding this video. Let's meet in another video.